Welcome to Business Analytics course. This is Dr. Aruna, Associate Professor, MBA Department from MLR Institute of Technology. In today's session, we are going to discuss about measures of association. In descriptive statistical measures, we are going to use different kinds like first we have seen measures of location, measures of dispersion, and the third part is measures of association. Now, in this measures of association, that means we are going to find out the relationship between two variables. So, here we are going to focus on covariance as well as correlation quotient. So, what is this measures of association? It is the statistical measure that describes the strength as well as the direction of the relationship between two or more variables. In this, again, we come across two things. One is correlation, the other one is covariance. So, covariance gives the information only about the direction, whereas correlation gives the information about the strength as well as direction. Now, moving forward, measures of association. So, it is a statistical technique used to determine the strength and the direction of relationship between two variables. Now, what does this help the statisticians, or what does this help the researchers? Now, this helps the researchers to understand whether the variables are related and how strongly they are connected to each other. Now, as we have seen in the previous slide, this includes two kinds of measures. One is covariance and the other one is correlation quotient. Now, let us see what is covariance. Covariance measures the direction of the relationship between two variables. The positive covariance means the two variables are moving in the same direction. Negative covariance indicates that the two variables are moving in opposite direction. Zero covariance states that there is no relationship between the two variables. Now, what is this positive covariance, negative covariance? Now, say for example, we have two stocks, say for example, stock A and stock B. Now, if the stock A is increasing, obviously, if both are correlated, positively correlated, if A and B are positively correlated, means when A is increasing, when the price of stock of share A or the stock A is increasing, automatically the price of B is also increasing. Now, if we say the negative covariance, or that means there is an opposite relationship between the two. For example, A is increasing. Now, we say that B is decreasing. So, the reason is both are having a negative relation, means both are moving in the opposite direction. In case if there is no kind of relationship, means we cannot relate with one variable with the other, obviously we say that there is no covariance, and that is called as, there is no relationship, and that is called as zero covariance. Now, let us see the formulas associated with this population covariance. Now, here in this covariance and correlation, we come across two types of varieties, that is, one is population covariance and the second one is sample covariance. Now, what is this population covariance and sample covariance? Say for example, the class strength is 60 members and its maximum limit is 60, and we are taking the total 60 members into count. It is called as the population. Now, in that particular class, if we are choosing in randomly any 10 members or any 9 members or some 15 members, that is called as sample. So, for sample, we would be getting one kind of answer, and for population, we are going to fetch another kind of answer. Now, accordingly, we are having a different formula for this population covariance and also sample covariance. Now, if you look at population covariance, measures the relationship between two variables in the entire population. As I have taken the example that there are 60 members in a class. So, entire 60 members strength if I am taking, and now this n becomes 60. So, this is covariance of xy is equal to and we are going to represent this as a sigma. Sigma xy is equal to summation I is equal to 1 to n, means we are going to take whatever the observations are there, all the observations xi minus mu x into yi minus mu y by n. Now what does this xi and mu x represents, and what does this yi and mu y represents? X and y are the individual observations, whereas mu x and mu y are the population means of x and y, and n represents the population size. Here in our example, it is total 60 members. The strength of the class is 60 members. So entire students we are taking, so that becomes the 60, that is n. Now for every measure of association like covariance and correlation, we do have the Excel functions. The Excel function representing the population covariance is covariance.p. By default in Excel we have the function covariance.p, where p stands for population, array 1 and array 2. In the next session we are going to witness how we are going to calculate this covariance using the formula and also using the finance function. So moving forward, let us see what is sample covariance. In the sample covariance, as I said, instead of 60 students in the class, we are going to select randomly some 15 members or 10 members or some 12 members, like that. Now sample covariance estimates the covariance of the population using sample data. Now in my example, the sample data may be either 9 members or 12 members or 15 members, whatever the number we are going to choose. Hence here the formula would be, it is represented, earlier we were using sigma xy, but here in the sample we are using sxy, where S stands for sample. Sample of covariance between x and y is equal to summation of I is equal to 1 to n. So all the observations xi minus x bar into yi minus y bar divided by n minus 1. Now what does this signify? Xi and yi are the sample observations, x and y are the sample means of x and y, n stands for the sample size, and here we are taking n minus 1, that is nothing but degrees of freedom. We call it as Basel correction. So whenever we are taking population, we simply deduct 1 from the total n. So n minus 1 becomes the degrees of freedom. Now accordingly, we are also having an Excel function called as covariance.s, array 1, array 2. Now we all know very clearly that whenever we are using the Excel function, we are going to use the equal to symbol. So we are going to put equal to sign and then covariance.s, since because we are representing the sample covariance, we are asking for sample variance, so we are using covariance.s, array 1 and array 2. So whatever the two variables array is there, that we are going to select the data. Now moving forward, the next one is correlation quotient. Now, as we have discussed in the previous slides, correlation quotient gives the information about the strength as well as the direction of the linear relationship between two variables. And obviously, the values also ranges from -1 to +1. Now, what does this -1 and +1 signify, or what does they interpret? So, if it is the value of R, that is correlation quotient, is generally denoted as R, Pearson's R, it is also called as Pearson's R. So if the value of R is +1, it indicates it is perfectly correlated. That means suppose if there are two variables x and y, and if the correlation quotient between the two variables is +1, it indicates that there is a perfect correlation, perfect positive correlation between the two variables. Now if it is from 0.5 to 0.99, we say that there is a strong positive correlation. If it is 0, then it is an indication that there is no correlation between the two variables. Now if it is -0.5 to -0.99, so it is called as strong negative correlation, and -1 indicates perfect negative correlation between the two variables x and y. Now how about if it is less than -5, whether it is plus or minus, less than +0.5 and less than -0.5, it implies there is partial positive correlation and partial negative correlation. Okay. Now let us see the formula associated with this. So population correlation quotient. So like covariance, even for this we are having population correlation and also sample correlation. But the interesting thing is that even for population as well as the sample, we are going to get only the same answer. We will see how exactly that is going to take place. Now, the population correlation quotient measures, since we are talking about the correlation, it is nothing but strength and direction of the linear relationship between two variables which are taking place in the entire population. The formula associated with this, now it is represented, that is population correlation quotient is represented as rho. Rho is equal to covariance of x and y. That means the covariance which we have calculated in the previous slides, that value divided by standard deviation of x and standard deviation of y. So where rho stands for population correlation quotient, covariance of x and y is nothing but the population covariance, standard deviation of x, sigma x is the standard deviation of x, that is population standard deviation, and sigma y is population standard deviation of y. And now the Excel function we have by default. Earlier for covariance we were having covariance dot p for population and covariance dot s for sample, but unlike that, in correlation we have only one function, that is correl array1 array2. So the two variables array we are going to give, and we are going to use the function correl. Now if you see the sample correlation quotient, the formula changes. The sample correlation quotient estimates the population correlation using sample data. So instead of total population, we are going to use sample data, which is represented as small r. Now that formula is summation xi minus x bar into yi minus y bar divided by standard square root of summation of xi minus x bar whole square into summation of yi minus y bar whole square. Now what does this signify, or what does that tell? R stands for sample correlation quotient, x bar is the sample mean, y bar is the sample mean for y observations, xi and yi are individual observations. Now if you look at the previous formula which we have used for population correlation, the same formula we are going to use is equal to correl array1 array2. So these are the formula which are used under correlation and quotient, and that too population covariance, sample covariance, population what you can say, population correlation, and also sample correlation quotient. Now for sample correlation quotient there is an alternative formula also. R is equal to S of xy divided by S of x into S of y. So what is this S of xy? S of xy stands for sample covariance, whereas Sx represents sample standard deviation, and S of y represents sample standard deviation of y. So the sample standard deviation of x variable and sample standard deviation of y variable we are going to take into account along with sample covariance in the numerator part. Now sample covariance or Pearson's R is the most commonly used measure of correlation in statistics. In most of the cases we are generally going to focus on sample correlation. Now, in this session, we have gone through what are the measures of association. One is covariance and the second one is correlation quotient. We have also seen the covariance is nothing but which signifies only the direction, means it measures the direction of the linear relationship between the two variables. Okay, but in correlation quotient we are going to discuss about the two types, that is the strength as well as the direction. Both factors we are going to look into with respect to the two variables. And moreover, in covariance we are having population covariance and also sample covariance. Similar to this, even in correlation quotient we are having population correlation quotient as well as sample correlation quotient, but the difference is when it comes to the Excel functions, for both population and sample, we are going to use the same function, Corel array 1, array 2. But whereas for Excel functions with regard to covariance, for population we are going to use covariance.p array 1, array 2, whereas covariance.s array 1, array 2 for sample covariance. Now, let us summarize what exactly we have seen, what functions, because in the next session, we are going to make use of all these Excel functions. Now, for example, if we take the first one, that is population covariance, so the formula is covariance.p array 1, array 2. So, here we are going to use dot P. Now, sample covariance, when we are using sample covariance, we are going to use dot S, array 1, array 2. Now, if we look at the population correlation quotient and sample correlation quotient, population correlation quotient is represented as rho, whereas sample correlation quotient is represented as R. But both of these are going to have the same default Excel function, that is simply Corel array 1, array 2, and here also Corel array 1, array 2. Now, alternative correlation function is also available in Excel, that is Pearson array 1, array 2. Please note down that in Excel there does not exist separate functions for correlation quotient, unlike that we are having for population covariance and sample covariance. Thank you. Let us stay tuned, and in the next session, let us discuss the same measures, that is measures of association, how exactly we can do it in Excel, and how these functions can be executed so that we are going to lead to same results. Thank you.